Hello friends, so today we'll be discussing a problem on differential equation. Okay, and this was asked in yes GATE. Okay, so for previous problems and other problems you can visit this link, and the link is given in the description of this video. For the CSIR NET linear algebra, February 2022 and September 2022, you can also visit the link which is given in the description. So let's proceed to the problem. So we need to solve the Cauchy problem, which is del u by del y minus x del u by del x plus u minus y equals to 0. And the condition is given that ux0 is equal to sine x. And we need to find out the value of u01. Okay. So I recommend you to pause the video and try for a solution, and then we'll discuss the solution in detail. Okay, so I hope you tried for a solution. So let's recall that the Lagrange auxiliary equation for the linear partial differential equation P del u by del x, Q del u by del y equals to R. This is given by dx by P, so the coefficient of del u by del x, dy by Q, the coefficient of del u by del y, and del u by del R, which is this. Okay, so let's write down the auxiliary equation for the given differential equation, which is del u by del y minus del u by del x plus 1 minus u. I guess this was the equation. Yeah, u minus 1. Okay, u minus 1. So let's write minus u. Okay, so yeah, so the given differential equation, so I can rewrite the differential equation as minus x plus 1 and minus this. So this is my here p is equals to minus x, q equals to 1, and r equals to minus of u minus 1. You can also write 1 minus u, no problem. Okay, so then I'll apply the the Lagrange auxiliary equation. So what is this? Minus dx by x. So dx by minus x, which is same as minus dx by x, equals to dy by 1 equals to minus du by u minus 1. Okay. So we need to solve this. Okay. So what we will do, we'll consider these two and then these two. Okay. So let's consider the first two terms, which is equals to minus dx by x equals to dy by 1. Now integrate this, what we will be getting, minus ln x plus the constant ln c1 equals to y. And this I can write ln of c1 by x equals to y. And therefore, this is what? c1 by x equals to e to the y, and therefore c1 equals to x e to the power y. So this is the first constant. Okay, and that is what we need to determine first. Okay, so this is my first constant, c1 equals to x e to the power y. Similarly, considering the last two terms, dy by 1 equals to minus du by u minus 1. That's similar to the first one. This is y equals to, again integrating will give me minus ln of u minus 1 plus ln c2. And this is again, I can write y equals to ln c2 by u minus 1, and hence c2 equals to u minus 1 e to the power y. So we have c1 equals to x e to the power y, and c2 equals to u minus 1 e to the power y. And then what is the solution of the Lagrange differential equation? It's like you write some arbitrary function phi of c1 comma c2 equals to 0, or this we also write this as c1 equals to phi of c2. Okay. and where this phi is an arbitrary function that we need to determine using the initial conditions. Okay. So general solution of the given differential equation will be C2 equals to phi of C1. Okay, or you can write C1 equals to phi of C2 also. Whatever, like the easiest thing that you write and solve it. Where phi is an arbitrary function. And now, so using the two equations, C2 and C1, I can write, and using this condition also that ux0 sin x, what I can write? C2 was u minus 1 e to the power y, and C1 was x e to the power y. Look at this. Now, I'll just put y equals to 0. So, u is basically uxy minus 1. Okay. So, if I put y equals to 0, I'll be getting sin x minus 1 e to the power 0 equals to phi of x. Okay, because e to the power 0 is 1. So, therefore, phi of x equals to sin x minus 1. Okay. So, now what I got is C2 equals to phi of x is sin x minus 1. So, it's a sine of C1 minus 1. This is the condition. Now, I just use this. I also have this. So, I'll just put u minus 1 e to the power y equals to phi of x. So, sine of x e to the power y minus 1. So, this. And now what we need to determine the value at 1 comma 0 comma 1. So I'll just put x equals to 0, y equals to 1. So u01 minus 1 equals to e to the power 1 equals to x equals to 0. So sine 0 minus 1, this vanishes. And therefore u01 equals to, so this is my e. So right. So this is my u minus u01 minus 1 equals to 1 by e. And therefore u01 equals to that's minus e, sorry, is 1 minus 1 by e. Okay, so this is 1 minus 1 by e. And therefore, the final answer will be 1 minus 1 by e. And this Cauchy problem is usually asked in NET, GATE, everywhere. Okay, so what we'll do, we'll first solve the PDE and then we'll apply the condition. That's it. We don't have to do anything. Okay, so thank you for your time and patience. We'll meet again. A new problem that is on miscellaneous, and that's on the functional analysis. And that was also asked in GATE. Okay, so thank you, goodbye, take care.